Welcome back to LPC channel today. So in today's video, we are continuing with our discussion on classification of data, and today we are looking at how to use Sturge'S rule to actually draw a simple group frequency distribution. So if you could realize, you have watched the previous video, you can clearly see that the question that we use, the same question we're going to use to actually discuss the concept of Sturge'S rule in drawing a simple group frequency distribution. So if you are new on this channel, hey, please make sure to like this video, subscribe to the channel, and then share. Please do well to like this video as well. So let's jump in right away without wasting my time. Now, we are asked to draw a simple frequency distribution using what? Sturge'S rule. So we are asked to use Sturge'S rule. But what does the Sturge'S rule state? The Sturge'S rule actually states that, so Sturge'S rule, XR, it says that for us to calculate, it will help us to calculate the number of classes actually desired. Okay, and there's a formula. It is what? 1 plus 3.22 log to the base of 10, log 10 to the base of what? N. So this is the rule or Sturge'S rule that help us to calculate the number of class for a particular set of what data where we want to have a group frequency distribution. So it is 1 plus 3.22 log 10 to the base of what? N. The N is the total frequency under consideration. So let's be guided about that. All right. So let me raise this from here so that we get it done in this case. All right. So now, having gotten that, these are the steps we go through to use the Sturge'S rule approach to actually come out with the number of what classes that we will use for grouping of this set of what data. Is that okay? So one, the first step is find the highest and the lowest what value. Find the highest and the lowest value of this set of what data, or find the highest and lowest value of any set of data. So you can clearly see that the highest value of this set of data was what? 75, right? And the lowest value is what? 35. So we have the highest value to be equal to what? 75, and we have the lowest value to be equal to what? 35. So that's the first step. You locate that. The second step is to find the range. How do you find the range? So to find the range is simply saying the difference between the highest value and then the lowest value. Simply saying the difference between the highest value and then the lowest value. That will help us to find the range. So this is the first step, step one. So second step, to find the range, and we said to find the range is equal to the highest value minus what? The lowest what value. And we know the highest value in this case was 75, and we know the lowest value was what? 35. So what is the difference between 75 and 35? So we're gonna have here 75 minus what? 35. And that should fetch us what? 40. So we're going to have here to be what? 40. So that's the second step. The next step you want to undertake using the Sturge'S rule is to find the desired number of class. That's why we use the Sturge'S rule formula to actually calculate that. So in using the Sturge'S rule, that's going to the step 3. That's going to the step 3. Step 3, we are saying that Sturge'S rule XR is going to be 1 plus 3.22 log 10 to the base of what? N. And in this case, the N is the total frequency, or number of what? Frequency in that particular number of sets of what? Data, or total what? Frequency in this case. I believe that is clear. So after getting your range, which is the highest value minus the lowest value, the next step is to calculate your desired number of classes in this case. And how do you do that? We calculate that by using the Sturge'S rule, which says that the rule should be what? 1 plus 3.22 log 10 to the base of what? N. When we know the N is a total frequency in this case. So we know that from this data, you can clearly see that the total number of frequency here is what? 20 here. So you can say that in using the Sturge'S, we can see that here is going to be 1 plus 3.22 log 10 to the base of what? 20. Is that okay? So let's go back to our calculator. 1 plus 3.22 log 10 to the base of what? to the base of 20, we're going to fetch what? 5. We're going to have here to be what? 5.1893. But under Sturge'S rule, we deal with what? A run-up approach. We deal with a run-up approach what? More often. Is that okay? So running up a number means if there is any remainder that comes after any number, it is being rounded into what? A whole number. That's how you run up a number. But running off a number, that's where we deal with what? The code and then the odd number. As in, if the number is less than 1, then it's taken as what? That same number. But if the number is greater than what? 0.5 or is equal to 0.5 or greater than 0.5, that's where we run it to what? A whole number. Is that okay? But in running up a number, we run up a number where there is what? A remainder or a decimal, whether it is less than 0.1 or greater than 0. Or equal to or greater than 0.5. So in running up, we just run up the number. All that we are trying to say that if there is a remainder, run up to the nearest or the nearest what? Whole number. So in this case, since we are running up, this number is going to what? Going to approximately what? 6. Because in running up a number, we deal with running up a number where we have what? Remainders. I believe that is clear. So that is the whole idea in this situation. All right, so it's going to be rounded to what? 6. All right, so once we get to know of, so it is going to be the number of classes going to have for the various class interval. The number of classes, we're going to have 6 classes to have our frequency being grouped and then under this class. So after getting the number of classes, the next step is to find the size, the class size or the class width. You can recall the class size or the class width. And how do you do that? To find the class size or the class width, that's step 4. You are saying that to find the class size or the class width, so define the class size or the class width. Class size or the class width, it is equal to the range. The range is equal to the range divided by what? The number of class that we have computed. The number of class that we have computed in this case. I believe that is clear. So now we know the range in the question. We have calculated the range to be what? 40. So the range is going to be 40, and the number of class in question here was what? 6. So let's take our calculator. So 40 divided by 6 should be able to help us to arrive at what? Should be able to arrive at 6.667. So here too, we are going to run up. So here we run up. So let me add this. So we round or rounding up. We round up the numbers. Is that okay? Likewise here, you're also going to run it out by saying that it's going to be approximately what? 7. So rounding up, and then that is all. So 7. So meaning that our class size or our class weight from the lower class limit and upper class, and the difference should be what? 7 in that case. Is that okay? So once we get the 4th step, the next step, which is the 5th step, is to find our lower class limit for the various classes we are going to what? Have in this case. Because we know our classes should what? 6 classes based on the Sturge'S rule formula that we use. We computed that, or we arrived that it should be what? 6 classes, which we run it up to 6. I hope that is clear. So now to get to the next step that we're going to do is to help us to calculate how to get the lower class limits for the various classes. And how do you get that? You get that by first of all identifying from the given set of data the lowest value automatically, which is going to be the lowest class limit for the first class. So you can clearly see that from this set of data, 35 is the lowest value, which in this case is going to be what? 35. So 35 is going to be the lowest class limit or the lower class limit for the first class. And to get the next lower class limit for the next class, all that we need to do is to add what? Our class weight, which is what? 7, and that will help us to get the next lowest class limit or the lower class limit for the second what? Class. And when we add 7 plus 35, it's going to fetch us what? 42. So we're going to have here to be 42. So this is our next lower class limit. And then for us to get the third class lower class limit, you also add 7 to 42, and that will help us to get what? 49. And it continues to get what? 6 classes. So we add 7 to 49, that will fetch us what? 56. You add 7 to 56, that will fetch us what? 63. And then you add 7 to 63, and that will fetch us what? 70. So you realize that we have 35, 1. We have here to be 1, 2, 3, 4, 5, and what? 6. So mean that we have gotten our lower class limit for these classes. Is that okay? Right. So once you have gotten that, the next step is to find also our upper class limit. So now we have this. We have 35 hyphen, and we have 42 hyphen. We're gonna have our 49 2 here as our lower class limit for the third class. Then 56 as our lower class limit for the fourth class. Then 63 as the lower class limit for the fifth class, and then 70 as the lower class limit of the sixth class. So now once you're able to get this, therefore we can show that we get our upper class limit for various class, which is going to be, so 35 mean that the next class start from 40, so mean that 35 is going to end at what? 41 as the upper class limit of the first class. Is that okay? And then 42 here, it ends at 49, so it means they're going to end at what? 48, which is going to be the upper class limit of the second class. And then from 49 here, it ends at 56, or it start at 56, and then end at what? 55. So here, since it start at 56 and here it start at 63 as the next class, is going to end at what? It's going to end at what? 62, right? So let's take note of that. And then here 63, it starts at 7, so it's going to end at what? 69. And here when you also start at what? 7, so you're going to end at what? 76. Because at the end of the day, when you are to compute for the class width or the class size, they should have what? A class size or class width of what? 7 here. That we rounded up. Is that okay? So let's take note. So it means that it starts at 35 and ends at 41, and the next class start at 42 and end at 48, and the next class continue in that manner. So this is going to be our class what? Our classes. So it's going to be from 35 to what? 41. Is that okay? Then from 42 to what? 48. Then from 49 to 55. Then from 56 to 60. What is it? 56 to 60 what? 2, right? And then from 63 to what? 69, and then from 70 to 76. This is going to be our classes that we're going to have in this case, which is going to be 1, 2, 3, 4, 5, 6. So it's going to be our 6 classes we're going to have in this case. So this is going to be our class limit. Our class what? Limit. Our class limit in this particular case. So once we're able to calculate our class limit, the next step is to calculate or find the number of frequencies for that will fall within each class limit. So you come to tally, because after tally you get your frequency, right? So from tally, before even the frequency, let's come back to the class boundary. That's where we have class boundary coming in here for us to be sure of our class width or the class size. And then lastly, the frequency, right? Sure. So now from 35 to 41, we have just what? 35 that will fall within. Or do you have any? Take your time. Do you have any? 40? Okay, let's see. So 60, 45. No. 70, 58. So you can clearly see that it's only 35 that falls within 35 and 41. That will go into both one stroke, and that's going to have a frequency of what? 1. I hope that is accepted. Now let's go back to 42 to 48. So 42 to 48, now we have 45 here, we have 42 itself, we're making it 2, we have, and then we have 48 here, making it 3. So you have for 3 frequencies, so that will fall. So we're going to have a 3 strokes, 1, 2, 3. That's going to fetch us what? 3 here. Is that okay? So once we are done with 42 and 48, we move on to 49 and 55. So 49 and 55 as the next class, we have 55 here as part we have 54 here as part, which is 2. We have 50 here as part, which is 3. And then we have what? We have also, let's see, we have also 51 as part, making it what? 5. 52, 6. I think that is also, we have what? We have here 55, which is 1. 54, 2. Then 50, which is 3. Then we have 51, making it what? 4. And then we have 52, making it what? 5. So within this range, we can have what? 5 tallies or 5 strokes. 1, 2, 3, 4, and then you have your last one being cross that, and that making it what? 5 as the frequency in this case. And then we come at 56 and 62, the range of 56 to 62. Let's see. So in that too, we can talk about 60 here, which is 1, and then we can continue to, so we have 60 here. I think that is all. That is all. And then so 60, that's on the first row. Then you come to 58, which is 2, and then what again? Another 58 here, making it what? 3. So you have here to 3 strokes, which is what? 1, 2, 3, and you have your frequency to be what? 3 here. Is that okay? And then move on to the next class, which is what? 63 to 69. So 63 to 69, let's see. So mean that values from 63 up to 69 should be within 63 to what? 69. So let's see those values in here. So on the first row, okay, we have 65 here as 1, 65 as 1, and then we have 68 as 2. Is that okay? And then we come back to 64 as 3, and I think that is also, we have 65, 68, and 64, and that will make it what? 3. So 3 strokes, 1, 2, 3, and you have your frequency to be 3 here. Is that okay? And then lastly, the last class is 70 76. So let's see. So on the first row, we have 72, 1, capture that, and then we have 74, 2, capture that, we have 73, capture that, and then we have 75, 4, capture that. So it's going to be what? 4 strokes, so going to be 1, 2, 3, 4, and you have your frequency as 4 indicated here. At the end of the day, your frequency should sum up to what? 20. So let's see. 1 plus 3 will fetch us what? 4 plus 5 will fetch us 9. 9 plus 3 will fetch us what? 9 plus 2 will fetch us what? 12, right? And then so there's something missing that we need to verify. Is that okay? Because when you add up all, let's see 1 plus 3, 1 plus 3 plus 5 plus 3 plus 3 plus 4, we are getting 9, to mean that there's one frequency out. Let's find that one before we continue. Actually, the problem was coming from here, that 56 to 62. Realize that we have from 56 to 62, and as our class interval, we have here, we have 60 here as a 1, and we have that of the next should be okay. So the next from 60 on the first row, that is all. When it comes to the second row, we have what? 50, which is 2. Then we have 60, which is what? 3, and we have 50, which is what? 4. So we didn't include what? The 58 as part of it, and then we just indicated 3 strokes. So here should be what? 4 strokes, and then that should alter here to become what? 4. All right, so that should be what? 4 in that case, as the 56 to what? 62. So in that case, then we can clearly say that here should be what? 20 when you add up. So that's going to give us 1 plus 3 plus 5 plus 4 plus 3 plus 4. That should fetch us what? 20, as we have gotten here. So that's how it should be. So once you have gotten the class limit, the tally, and then the frequency for this particular data, for which we know was what? 20. The next thing that you want to find our class boundary. So to find your class boundary, it is the difference between the upper class limit of the first class taken from the lower class limit of the second class. So if I'm taking the first 2 class limits, I know the upper class of the first class is 41, and the lower class limits of the second class is 40. So the difference between the two will fetch me 1. So when I get 1, I'll divide it by 2, and that's going to fetch me 0.5. So to get the class boundary for the first class limit, I'll subtract 0.5 from 35, which is the lower class limit of the first class, and then add 0.5 to 41, which is the upper class limit of the first class. So it means that here I'm going to have my class boundary to be 34.5 to 41.5. I believe that is clear. Then it continues here to 42 to 48 is going to be 41.5 to 48.5, and then it continues in that manner. So here I'm going to have here to be 48.5 to 55.5. Then you have here to be 55.5 to 62.5, and from 62.5 to the next class, move on to what? 69.5, and then lastly, then I have here to be 69.5 to 76.5, and this will determine your class boundary for this particular set of data using the Sturge'S rule. So in using the Sturge'S rule to actually calculate or draw a simple group frequency distribution actually makes it uniform, because where we were using our own desired class interval, that's where you can have different class limits coming in, yes, still getting the same frequency of 20. But where we have a uniform formula or a method that helps preparers of this frequency distribution table, it helps to avoid variations in data sets and then method that we use for it, and therefore ensure uniformity of data set. So that's one advantage of using Sturge'S rule to draw a group frequency distribution table. It helps to avoid variations that comes as a result of using different class limits or class interval to calculate, where there is an absence of Sturge'S rule to help us to know the desired number of classes that we need to have for a particular set of data. And that's what Sturge'S rule does. Is that okay? So that is all about Sturge'S rule in that case. So thank you for watching this video. So if the video was really helpful to you, please go ahead to smash the like button and make sure to share this video as well, and like it as well, so that we get more engaged in that case. So I'll see you in the next session, where we continue or we discuss a categorical method of classifying data. Thank you and bye bye.